The critical value is the quantile that gives a certain probability in the tail of a distribution. The probability is called the significance level. The lower tail refers to the region from the critical value to negative infinity. The upper tail refers to the region from the critical value to positive infinity. You can calculate the critical value for the upper tail, for the lower tail, or for two tails. Let's go through each scenario. Suppose you have a t-distribution with 100 degrees of freedom. You may want to find the critical value that gives a probability of 0.1 in the lower tail. You can use the t-inverse function to find the critical value. For the probability parameter, select the significance level. For the degree freedom parameter, select the degrees of freedom. Press F4 to lock in the reference. The output tells you that the critical value is -1.29. You can do the same to find the critical value for other significance levels. Common significance levels are 0.05, 0.025, 0.01, and 0.001. When the degrees of freedom is large, the critical values under the t-distribution are similar to the critical values under the normal distribution. You may want to find the critical value that gives a probability of 0.1 in the upper tail. There are two ways to do this. Method 1. The first way is to use the t-inverse function. For the probability parameter, enter 1 minus the significance level. The t-inverse function only gives the critical value for a probability to the left of it. However, the total probability under the curve is 1. So the critical value that gives a probability of 0.1 above it is the same as the critical value that gives a probability of 1 minus 0.1 below it. For the degree freedom parameter, select the degrees of freedom. Press F4 to lock in the reference. The output tells you that the critical value is 1.29. A sense check tells you that this is correct, because the normal distribution is symmetrical around the center, and 1.29 is the symmetrical point to -1.29. You can do the same to find the critical value for other significance levels. Method 2. The second way is to remember that the critical value for the lower tail is symmetrical to the critical value for the upper tail, so if you already have the critical value for the lower tail, you can take the absolute value of that to get the critical value for the upper tail. Use the ABS function to find the absolute value. You can see that the two methods give the same answer. You may want the critical values for a significance level of 0.1, split across the two tails. There are two ways to do this. Method 1. The first way is to find the critical value for each tail separately. The critical values that give a significance level of 0.1 split across the two tails is the same as the critical values that give a probability of 0.05 in the lower tail or the upper tail. We've found the critical values for that are -1.66 and 1.66. Method 2. The second way is to use the t-inverse 2t function. For the probability parameter, select the significance level. For the degree freedom parameter, select the degrees of freedom. Press F4 to lock in the reference. The output tells you that the upper critical value is 1.66. The distribution is symmetrical, so the lower critical value is the negative of that, so -1.66. Together, the critical values are -1.66 and 1.66. The result is the same as under the first method. You can do the same to find the critical value for other significance levels. Common significance levels are 0.05, 0.025, 0.01, and 0.001. In summary, these are the functions to find critical values under the t-distribution. In older versions of Excel, The T inverse 2t function is called T inverse. For more lessons on statistics, visit alphas&betas.org.